this screencast, I'm going to give an example that will hopefully help you understand the definition of compact. To do this, I'm going to look at my favorite non-compact set, 0, 1, open, and my favorite compact set, 0, 1, closed. And I'm going to see how they differ when I look at a different sequence. So what I'm going to do is I'm going to create a sequence. Say A1 is going to equal 1/2. Right? A1 will be right there in the middle. A2 will equal about 3/4. A3 will equal 1/8. A4 will equal 15/16. A5 will equal, I don't know, 1/32. So basically, the formula we can write down is this, right? AN equals, I don't know, what does it equal? 1 minus 1/2 to the n. Is that going to be right? If n is odd, how about even? Yeah. And then it's just going to equal 1/2 to the n if n is odd. So that we could write down a specific formula. But the important thing is how it relates to these two sets. Right? The definition of compact says that every sequence has to have a convergent subsequence. Not only that, but that convergent subsequence has to converge to something in the set. So let's take a look at 0, 1, or non-compact set. This is certainly a sequence that's within 0, 1. The question is, and it has to have a convergent subsequence, that's Bolzano-Weierstrass. But the question is, does it converge to something in the set? That's what's going to make it compact. Well, you've got a whole bunch of things that are getting closer and closer to 1, right? Those are going to be the even terms. You've got a whole bunch of things that are getting closer and closer to 0. Those are the odd terms. The problem is that 0 and 1 aren't in the not compact set. So our normal candidates for a convergent subsequence here aren't even in this set. That's a problem. Whereas down here, 0 and 1 belong to here, so we can pick I don't know, maybe we'll pick the subsequence 1/n, which goes to 0, which importantly is in the compact set. Right? So that's basically what it means to be compact, is that you can find some sort of a subsequence that converges. Not only does it converge, but it converges to something within the set, which is a very closed type quality to have, which is why it's synonymous with closed and bounded. Whereas it's non-compact, right? No matter what you pick, if you want to pick any sort of a limit point, if you're going to try to find a convergent subsequence that converges to any sort of an L, you're going to find the L has to be 0 or 1. Because what happens is, well, you basically get this formula where eventually you're going to be arbitrarily close to 1 or arbitrarily close to 0, which means you will not be arbitrarily close to anything else because, right, I mean, you just get it close enough to 1 so that you're far away from L. So this has, right, you could do 1/n goes to 0, or you could do 1 minus 1/2 to the n. Sorry, those should be 2 to the n's. Converges to 1, but the problem with the non-compact sets is that 0 is not in here and 1's not in here. So the definition of compact says that you're going to be able to find a subsequence that converges to something within the compact set. If it's not compact, there will be a subsequence. There will be some sequence that has that doesn't have a subsequence that converges something within here. So this is the problem. You want to have a subsequence that converges to something in 0, 1, but 0, 1 is not compact, so it doesn't work out.